And we're back. Welcome back to the second tutorial on solubility curves to help you through this week's assignment. And you obviously see the same solubility curve on the right-hand side of the page that you saw in our previous video, if you've already watched that. If you haven't, it might not be a bad idea to go back and look at that to get an idea of some of the math that you'll have to do in solubility curves. And this is another one of the things that you might encounter. So the question here is asking how many grams of sodium nitrate, NaNO3, would precipitate out of a saturated solution in 100 grams of water at 60 degrees Celsius if we cooled it to 30 degrees Celsius. So there's a lot of words here, a lot of numbers. Let's break it down. First of all, this word precipitate here, I'm going to go ahead and highlight that. This word precipitate is really important to remember. Sorry about that. The word precipitate refers to a solid in a chemical reaction. Sometimes you can produce a precipitate when you combine two chemicals, but when a solid precipitates out of a saturated solution, that means it's no longer dissolved. So, where in a normal solution you would see just a transparent liquid, it may be colored, but you would be able to see through it, with no sign of any solid in that solution. When something precipitates, you would actually be able to see that solid in the bottom of the solution. So basically, what we're being asked here is how much of that sodium nitrate that we added in the beginning would no longer be dissolved. Sorry for the dogs barking in the background. It's been a long quarantine for all of us. So, the saturated part of this, the concept of a saturated solution is something that you've already seen in your web quest, or your scavenger hunt rather. And a saturated solution is one that contains an amount of solute equal to the solubility at that temperature. So the first thing we're going to want to do is to figure out the solubility at 60 degrees Celsius. Now, I've made it a little easier for you here because I've just asked you to figure out the solubility in 100 grams of water, which is exactly what this solubility curve tells us. We don't need to do any math to figure out what different amount would be dissolved. All we need to do is find where it says 60 degrees Celsius down here on the x-axis, then just go all the way up to where it crosses the curve for sodium nitrate, and we notice that the solubility of sodium nitrate, because this is 120 here, and this is 130, I'm going to call it about 122 grams per 100 grams of water. So, and again, we can use that number straight up because the solubility curve is based on the amount we can dissolve in 100 grams of water, so no conversions necessary. So now, we're going to cool it to 30 degrees Celsius. Now, you'll notice that as we do cool it, as we go from right to left on this curve, we're going to be able to dissolve less and less. That's usually the case for most solids. You know from experience that when you have a solid and you heat it, you're going to be able to dissolve more of it. There are some exceptions to the rule, but very few. So in this case, we know that we're not going to be able to dissolve as much at 30 degrees Celsius. And really the question is, how much less are we going to be able to dissolve? Because the amount that we can't dissolve anymore is the amount that we're actually going to see, the amount that's going to precipitate out, as we said. So we're going to find the 30 degrees Celsius mark. You'll notice that that's right here. We're going to go all the way up the curve, and at 30 degrees Celsius, we notice that the solubility is considerably less. I'm going to estimate, because it's halfway between 90 and 100 here. I don't want to clutter this screen up too much, but it's about halfway between 90 and 100, maybe a little more than halfway. So I'm going to go ahead and say that the solubility, again, excuse my handwriting, at 30 degrees Celsius is about 96 grams per 100 grams of water. Now, that means that at that temperature, we're only going to be able to dissolve 96 grams. If we added 122 grams in the beginning, we're not still going to be able to dissolve that amount. And the amount of precipitate, the amount of solute that we would be able to collect because it's no longer dissolved, is simply the difference between those two. So this sets up a really easy subtraction problem. 122 minus 96 gives us 26 grams of precipitate. So basically, if we were to kind of sketch out this solution here, we would see a whole bunch of clear liquid, and this would just be an NaNO3 solution, a solution of sodium nitrate, and that would actually be just a clear liquid. These two ions don't really have any color to them, and there would be just a pile on the bottom of 26 grams of solid NaNO3. Now, when we had heated it up to 60 degrees, all of that was dissolved. But now that we've cooled it down to 30 degrees, and now that we can't dissolve as much, we're going to notice that start to show up as a solid on the bottom of our container. So anytime you need to figure out how much would precipitate out or how much we would get if we dried something, it's usually going to be a matter of taking the difference in solubilities at those two temperatures. Because remember, a saturated solution contains the maximum amount that we can dissolve at that temperature, and that amount is going to be determined by your solubility curve. So I hope that helps. If you have any questions, you know where to find us, and I hope you have a great week.